The next thing we're going to talk about is something called piecewise functions. Now, when we were looking at domain and range, writing domain and range of different graphs, we saw something that looked kind of like this, where we have our graph really has two pieces. That really, whenever we saw it, is called a piecewise function, piecewise defined functions. Really what that means is we have different pieces of our graphs. And if you look at this line right here, this line has the y-intercept of -1. And if I find another point on the line here, we can see that from here to here, we go up 2 and over 3. This line has a slope of 2/3. So this line really is y equals 2/3 x minus 1. But we only are looking at this line when x is less than 0. This line, we look at the y-intercept is 3. The slope, we go down 1 over 1. Our slope is -1. So this is the line y equals -1x plus 3. And we're looking at this line when x is greater than or equal to 0. These two pieces together make our piecewise function. And this is how we would write it. F of x, our piecewise function, is 2/3 x minus 1, this line right here, when x is less than 0, and -1x plus 3 when x is greater than or equal to 0. Okay, so that's really how a piecewise function works. We're looking at this line when we have this x value, this line when we have this x value. All right, so we're going to go through just a couple things on this note sheet together, and you'll have some of this note sheet to do for homework for tomorrow, and then something else to do for the next day. So looking at piecewise functions a little bit more. We can evaluate functions either from the graph or from the equation. So if I'm finding f of 2, remember that whatever is inside the parentheses here is your x value.
Mama.
Yeah, kiddo? I'm making a video. Do you want to say hi to everybody? Those are my students. Okay.
Hi.
All right, so whatever is inside the parentheses here, that is the x value.
Mom, can I go to the bathroom?
Yeah, go ahead. Go ahead, kiddo. Whatever is inside the parentheses, that is your x value. So when it says to find f of 2, that really means what is the y value when x is 2? We can figure that out by looking at our graph, because we can find, all right, where is our x value? 2. Our x value is 2 right here. And then our y value is 1. So f of 2 equals 1. 1 is the y value. We could also use the definition for our function using the function definition that we had come up with up here. Our function, we had the piece when x is less than 0. We had the piece when x is greater than 0. So another way to evaluate the function is using the definition again. But in order to do that, we have to figure out, where is 2? Does 2 fit in when x is less than 0 or when x is greater than or equal to 0? Well, 2 is greater than or equal to 0. So plug 2 in to this piece. So we're going to take -1 times 2, right here, -1 times 2, plus 3. And let's see, -1 times 2 is -2, plus 3 is 1. And as you saw, we have the same value, f of 2 equals 1, however way we did this. All right, so another example here. At the top here, these lines were, the equations for these lines were written for us. Down here, we're going to write the equations of, looks like we have 3 pieces to our graph here. All right, so let's take a look at this line first. This line, if I continue it, would have a y-intercept of 3. Okay, that graph is going to cross the y-axis at 3. And if I find a couple points on the line here, from here to here, I can see that my slope of 2 over 1. Okay, my next piece, I have a horizontal line. So this line has a y-intercept of 1. And it's a horizontal line, so the slope is 0. And I'll do one more color for this line right here. This line, if I continue it, has a y-intercept at 0. And my slope, I go up 1 over 1. So my slope is 1. Together, these 3 pieces make up our piecewise function. So I'm going to call this piecewise function g of x just because it's a different function from the one we saw up here. This function g of x, we have 3 pieces. Okay, there are 3 different situations. This part first, we start with the farthest to the left. Our equation would be 2x plus 3 because the slope was 2 and the y-intercept was 3. And we use this equation when x is, it's an open circle here, so less than -1. Our middle part, our y-intercept is 1 and the slope is 0. So 0x, I don't really need to write that, plus 1. And we use that piece when x is between -1 and 1. We can't have the x value of 1 though, of -1. So -1 less than x less than or equal to +1. And then my other piece, the farthest piece on the side here, my y-intercept is 0, my slope is 1. So 1x plus 0, I don't really need to write the plus 0. And I use this piece when x is filled in circle, so greater than or equal to 1. Okay, so this would be the function definition for my piecewise function. Okay, so the back side, we're going to do a couple examples here, and then I'll have the rest for you guys to do on your own. The rest of this will go pretty quickly for you guys. We have 2 functions here. We have this piecewise function f of x and this piecewise function g of x. So using these graphs, I want to find, and I'm just going to do a couple examples here. I already made my answer key, so that's why I have my separate piece of paper here. But number 2 in front of you, f of -4. So this number inside the parentheses, that's our x value. The f is telling us what function to use, whether we're using this one or this one. So I want to see when my x value is -4, what's my y value? It's 2. Number 7, I have f of g of 0. There's a lot of stuff there. What I really need to do first is find g of 0. So in function g, when my x value is 0, what's my y value? That's 2. Once I know g of 0 is 2, Well, look at what we have now. I have f of, I know this is 2. F of 2 is, go back to function f. When my x value is 2, my y value is -1. Okay, the next section of problems, we have some equations, some piecewise functions given to us in their defined forms where we see the equations. Okay, and let's take a look at I don't know, let's just do number 11 here. Number 11, we have m of 4. When I'm trying to find m of 4, I need to figure out, well, when 4 is my x value in function m, what piece do I use? 4 is greater than 2, so I need to look at this piece. -3 times 4 is -12. Okay, it's the same process with all of these. Figure out where does this x value fit in the piece, and then plug it in. And then the last problem on here, we have a graph to do. We're trying to graph this piecewise function. And number 14, we have 2 pieces for our piecewise function. Again, I already did my graph, so I'm just gonna redraw something over here and do my best to make it look good. This first piece, x plus 2, we use that function when x is less than or equal to 1. So let's start off by trying to graph this line. X plus 2, the y-intercept is 2, and the slope is 1. We go up 1 over 1. I use this piece when x is less than or equal to 1. So I don't need to go any further to the right. I really need to go further to the left. So I'm going to draw a couple other points out this way and connect them. With my straight edge, and be careful to not keep going forever to the right because we only use this piece when x is less than or equal to 1. Our other piece, -2x plus 5, y-intercept is 5, slope is -2. We only use this piece when x is greater than 1. So I would have an open circle here because that's where our line is, this -2x plus 5, that's where our line is when x is 1. So those points really overlap. The end of our first piece of our piecewise function and the start of our second piece end up at the same spot. So this is what our final graph would look like for our piecewise.